Good day, stat students. So today we're going to look at Chapter 3, the relationship between quantitative variables. All right, and specifically we're going to go over Section 3.1, scatter plots. All right, but we have to talk a little bit about relationships between variables first. So like I said, this chapter is all about the relationship, and we're just going to look at two quantitative variables to keep it simple. Okay. So for an example, is there a relationship between how long a student studies, hours, and score on an exam points? So notice these two variables are what? They're both quantitative, right? And so hours. So if somebody asked you how many hours did you spend studying for a particular exam, you would say a number, right? And then points on an exam, it's a number. Okay, and so both of these variables are quantitative, and so that's what we're studying in this chapter. It's a relationship between these two quantitative, or not these specific two quantitative variables, but the relationship between two quantitative variables. Okay. However, I want to bring up something else here that we're going to study later on, is that the relationship between two variables, they don't always have to be quantitative. So look at the relationship between these two variables. Okay. We got smoking and lung cancer. We know that they're related to one another, but notice that these aren't quantitative, are they? Smoking. Do you smoke? Did you smoke habitually throughout your life? Yes, no. Do you have lung cancer? Yes, no. Those aren't quantitative. Those are what? Those are categorical. Okay, so we're going to see how mathematically we're going to calculate how researchers look at the relationship between two categorical variables, but that'll be later. Okay, but I wanted to bring up that when you're talking about the relationship between two variables, you're not just talking about necessarily about just simply two quantitative all the time. Okay, notice this one. Is there a difference in the genders regarding their average score on the math portion of the ACT? Okay, and so here we have one categorical, all right, gender, some people refer to it as sex these days, and then average score, right, score, and so we have quantitative, right, and so this is about the relationship between one quantitative, one categorical. That'll be also later in this semester. Okay, so I just wanted to bring up that just because we're talking about the relationship between two variables, that they don't always have to be quantitative. Okay, there's other types of situations that we can run into. Alright, so we're going to define these variables. We have two of them. Let's define them. And so, one, we have the response variable, aka the dependent variable. So if you're in another class and they start talking about dependent variables, they're talking about the response variable, but every stats book will talk about the stuff in response versus dependent. Okay, and so this is the main variable in the study. This is the one that we want to know why this variable is changing from person to person or thing to thing. Why did one person score a 90 versus a 70 for another person? There had to be reasons for that. Okay, so the response variable is sort of the main focus of the study. Okay, explanatory variable, aka the independent variable. All right, we test whether the response variable is at least partially explained by the explanatory variable. So obviously the explanatory variable does the explaining. We got it. Okay. However, these types of models that we come up with in statistics is not what we call deterministic. And so a deterministic model says that we have one variable that completely explains the other one. So as one changes, the other one changes perfectly with it. Okay, usually that is not the case. Okay, in statistics. All right, actually it's hardly ever the case. Okay, and so we test whether the response variable is just at least partially explained by the explanatory variable. One variable is probably not going to explain everything about the other variable. If it does, we probably don't have to use statistics at that point. Okay. Now, in some problems, you'll need to identify which variable is the response and which is the explanatory. Sometimes this is really easy for students, sometimes it's not. Sometimes it's really obvious. Okay, sometimes it's not. So now, For those problems where you're having trouble figuring this out, try this. All right, use time if possible. If it is obvious which came first, that's probably the explanatory variable. So let's say that we had score an exam. Okay, you got the score an exam and how many hours studied. Which came first? Did you study first? Okay, and those hours came first? Or did your score come first? Well, hopefully everybody says, well, of course, the hours came first. How many hours did we put into it? Well, okay, since that obviously came first, explanatory variable, okay, and the response variable, the thing that we're really trying to study, why is it changing from person to person? Okay, score an exam. And so use time if you're having problems. Now, does time always work? No. And in some studies, excuse me, in some studies, you don't even know which came first. They might come simultaneously. All right, and so and it's a big question mark which came first. Okay, that might happen. All right, and in some instances, the researchers might just have to get together and say, you know what, we're going to make this one's response, we're going to make this one the explanatory. But most of the time, it's pretty obvious. Now, when talking about the relationship between two quantitative variables, so this is only for two quantitative variables, this type of relationship, the response variable is going to get a y, okay, the letter y, and the explanatory would get x. So I always remember it, explanatory gets the x, okay, the explanatory is the x and the response is the y. You'll see why we have to label it x and y here in a little bit, and the scatter plots have everything to do with it. So here's an example. Is there a significant relationship between a city's latitude and its average January temperature in Fahrenheit? Okay, so let's think about this. Okay, we have to define which variable is response and which is explanatory in this problem. So what do you think? Think about it for a second, all right, and see if you can come up with the answer. Well, the answer is latitude is the explanatory variable. That'll get the x. Latitude comes first. Now, if you forgot what latitude is the measurement of north to south on the globe. Okay, and so the equator would be 0 degrees latitude. Okay, and then as you head up to the North Pole, I think the North Pole is 90, and then the South Pole is a minus 90 degrees latitude. Okay, and so as you so if you start at the equator and you move north, okay, the latitude is going to go up. Okay, so latitude, a city's latitude sort of come first. The city has to be established someplace. Oh, there's its latitude. Okay, what's its average January temperature going to be like? That's going to be the y. And I'm going to label it as AJT from now on, so I don't have to keep on writing average January temperature. Okay, again, that'll be in Fahrenheit. So what I did was that I looked up 10 different cities, okay, and looked up latitude and average January temperature. Notice we have some mixture of southern cities and some northern cities. Okay, so I'm going to push that off to the side. Okay, and we're going to go ahead and make our scatter plot now. Please know this. Okay, is that the scatter plot is a plot comparing two quantitative variables. Okay, so what I've done here is that I've gone ahead and created two axes in StatCrunch. Okay, I have latitude as the x on the x-axis. That's why we have to define the explanatory as the x. Okay, because it's going to be on the x-axis. Okay, and then you got average January temperature on the y-axis. Okay, so you got x and y, latitude and average January temperature, and we're just going to start plotting things. So we'll start with Miami. So Miami had a latitude of 26 and average January temperature of 67, so we're just going to put a dot there. So every time you see a dot, that's representing a city. It's representing an observation within our sample here. So Mobile, Alabama, you got 31 for a latitude and average January temperature at 50. Okay, and so on and so forth. So you got Lincoln and you got Norfolk and all those other cities. Okay, so you got all the cities in there. I want to note one thing is that note that Lincoln, Nebraska is at 41 degrees latitude and average area temperature 25, and Cleveland is at exactly the same place, 41, 25. Okay, and so you actually have two dots sitting there. Okay, you have two dots sitting there, and so I just wanted you to note that. Okay, all right, let's move on. That we'll go ahead and have the computer draw the trend line for us. So here's our trend line. We're going to give a name to that trend line later on, but for right now we'll just call it the trend line. And notice that we have a negative relationship here. So there's different ways of naming this in mathematics. In statistics, we generally call things negative relationships or positive relationships or no relationships. So why is this one a negative relationship? So notice here that as latitude goes up, what's happening to average area temperature is going down. Okay, and actually the way we like to talk about this is that as x increases, y tends to decrease. And so you can, I'm sure I can find a variable, not a variable, but a city that sort of bucks this trend. Okay, and so that's why we say tends to decrease. Okay, all right. So we can also have a positive relationship. Here we've changed the variables. Notice our x variable is height and our y variable is weight. Okay, and so generally speaking, when we think about height and weight, is that there is a relationship with that, and as height goes up, so does the weight. But obviously we could have some observations that also goes against that trend. Okay, but what are we going to say about a positive relationship? Notice how our slope is here. Okay, the reason why we call it a negative relationship, let me go back to the negative relationship. The reason why we call it a negative relationship is because the slope of this line is negative. Okay, and the reason why we call this guy right here a positive relationship is because the slope is positive. All right, and so as height goes up, so does weight. At least it tends to, anyways. Okay. What about this relationship? We got a big blob of nothing, really, what we got here. So we got weight, a person's weight, and how often they're on the internet. And I forgot how if this was on a weekly basis or how many minutes. I don't remember what we were trying to measure here. But this was from a real file, okay, that we collected from students, and so I just didn't make it up. And so weight and how often they're on the internet. Okay, so notice here that we have a trend line, and when the trend line forms a straight horizontal line like this is an indication that there's no relationship between x and y. You got a big blob of nothing here. Okay, and that we don't have a clear, real clear slope here with the trend line, and meaning the slope is very close to zero. All right, and so when you got this big blob of stuff that just doesn't look like it's trending one way or the other, okay, well, we probably have no relationship between x and y then. Now we can have also these types of relationships, okay, and so you have a parabola here, okay, and actually we're gonna see this again in another section, this exact graph, okay. Now I want to bring this up. Now statistics can certainly handle this, okay, where it's non-linear, okay. However, that's getting into some more complicated things, and if you wanted to learn about how to do this, you might actually have to take a regression class, what we call regression analysis. That's eventually what we're going to call this analysis, is regression analysis, okay. And so here we're only going to be working with the linear stuff, okay, where we have lines, linear, where the relationship can be shown with a line, okay, such as the negative relationship here or the positive relationship, okay. And so can we handle this? Yes, but we're not going to handle it in this class, okay, but we should recognize it because it's actually going to help us understand something later on, okay. All right, so let's move on. So what should we be looking for or maybe questioning when studying a scatter plot? So we shouldn't just make a scatter plot and say, okay, there it is, okay, and not look at it. All right, we should take a couple couple of minutes and just see what the scatter plot is telling us. So one, what should we be looking for? What is the average pattern? Does it look like a straight line or is it curved? We just talked about that. Okay. Two, what is the direction of the pattern? Is it positive or negative? Or for that matter, no relationship. We talked about that. We didn't talk about this one. How much do individual points vary from the average pattern? So what am I talking about here is how spread out are the observations around the line? Are they really close to the line? Or are they really kind of spread out? So let me give you an example here. So notice we have two negative relationships here. Okay? But clearly they're different from one another. And I got a question for you. Which one do you think is the stronger relationship? The one on the left or the one on the right? The stronger relationship. Which one do you think? Hopefully you say it's the one on the left. Why? Your intuition tells you is that when the dots are really close to the trend line here, that's a stronger relationship versus that you have more variation around the line like you do on the one on the right. So we're going to take a look at that and how to measure that later on. Okay? Alright, let's move on. Fourth thing, are there any unusual data points, meaning outliers? Okay? Or outliers. So do you have observations that kind of bucks the trend? Well, let's take a look at this scatter plot right here. Okay? So this is a very strong relationship between X and Y, wouldn't you say? Okay? Very little variation amongst the dots there around the line, right? Okay, well, let me throw in an observation that sort of throws us off a little bit. So notice here that I threw in did you see where the observation came in? Right there. Okay. And notice it shifted the line. We're going to talk about that later on. This would be considered an outlier, this guy down here. Now why? Well, notice here is that generally speaking we have a positive relationship. As X goes up, Y tends to go up. Alright, so that means as X increases, say up to 20, we expect a higher Y. But notice we actually got a low Y here. Okay, when X was at 20, we had a value around, I don't know, I would say around 201 or so. Okay, where we were expecting a number around 15 to 20. Okay, so that would be considered an outlier, just goes against the trend. Okay, so these are the things that we should be looking at when we take a look at a scatter plot. Okay, so that ends section 3.1. Thank you for